I'm Richard Pablo. I'm one of the lead engineers in Asavi. We're working on the IoT sector. What we do in Asavi, we pretty much provide private networks on the edge. So if you imagine that you put a SIM card on your phone or any device, that device is going to be automatically into a private network, and that shows that can give you a lot of advantages when you deploy an IoT, and that's what we're going to be talking about in these IoT provision solving a nightmare. Before we continue, how many of you are working IoT? Great, and cool. How many of you are interested in IoT? Okay, so we're going to be today we're going to be talking about what is IoT provisioning. We're going to be talking about a little bit of IoT numbers, type of IoT provisioning. We're going to have a sample project with headless devices and a sample project with Greengrass. We're going to show how do you provision those type of devices. So first of all, what's provision? What's IoT provision? Provision is pretty much when you put your username and password onto a device. That's provision. You just provision your device with AWS, with Google, with iCloud, whatever. In IoT, it's exactly the same. It's just instead of username and password, you're using certificates or any other type of key that you can authenticate that device with the cloud where it's going to send the data. That it is. So in a standard mobile, you have one person per device. And in IoT, you have one person per thousands or millions of devices. So that's kind of the ratio that you have there. So in a standard mobile provisioning, you, the person, put the username and password onto that device. So you get a new phone, you put your one there, and you do the same with the computer. But when you have thousands of devices, it's going to be kind of difficult to go to each one of those devices and put in the username and password again and again and again. So you need some sort of system to help you around doing that, some sort of automated way to do it. So let's talk about a bit of IoT numbers. So this is a prediction of the IoT devices per person over time. So this is like 6.5 devices per person. We're a bunch of billions of people in the world, so multiply that by 6 is a lot. And then the IoT versus non-IoT devices. There's going to be kind of an inflection point by 2021 where we're going to have the same numbers of IoT devices and non-IoT devices. So an IoT device is pretty much like the one that doesn't have a human on the back to fix stuff when things go wrong. And then after that, there's going to be keep growing and growing and growing. On top of that, we are kind of IoT has been around for a long while, and then we've been going through some stages in IoT. So we were in the monitoring stage. We wanted to know what's the weather data. So we have a lot of weather sensors around the world. That's IoT. That's published into the internet, the actual weather data. But we are only monitoring that. Then we have analytics. We are running analytics behind that data. And then we have human reaction. This is the well-known predictive maintenance. You put a sensor on your device, and then you have a human that goes there and fixes the stuff. But we're going to the automated reaction. So those are the traffic lights. They react in real time without a human to intervene to change the volume of traffic of certain parts of London or any big city. So I wanted to show you guys kind of, for the ones that don't work in IoT, this is kind of a true story for many people. This is kind of an IoT project tale. So the first part of IoT is very nice. You start with like a small device, you do your demo, your boss is happy, everyone is very nice. And then you do your first deployment, things go well, you analyze, you feedback again, and everything's working well. And then you keep deploying stuff, and then more customers are attracted to it, and more people. And suddenly you go full blown, and you go across the world, and you're really happy. You can tell your kids what you did. That's really cool. And suddenly a guy comes and say that there's been a problem, and we need to change the search of all the devices. So these are recordings of the engineering lead of a meeting receiving those news. So in this talk, we're gonna be talking about like how to help around that. And then there's kind of 3 provisioning methods out there. So one of them is a factory provisioning. So this is, imagine traffic lights, okay? So in the factory provisioning, in the factory, they will put the identity onto that traffic light or the traffic sensor, the flows. So that means that when they put that certificate, they know exactly that this is going to go to London. So that traffic light is a London traffic light. So from the factory, that is destined to London. That's not commodity hardware. That is destined to something. So if that fails, you have to go all the way back to the factory and do the same thing. The advantage of that is fast deployment. You just build that thing and deploy that. It's really good. So, but then the disadvantage is that every device is unique from the factory, and they're not commodity hardware. So some of them have standard credentials. They're easy to hack. Like if you were familiar with the Wi-Fi routers back in the day, they all have the same password from the factory. They're easy to hack. And then it's hard to change when things go wrong. So if something goes wrong, you have to go and install a new device there because it's embedded in the chip. Then you have another one, which is during deployment. So this is the typical installer that goes and is installing the traffic flow sensor, and then it puts the certificate or the keys onto that device. So the advantage of this is that you have standard devices out of the factory. You can build flow sensors for all around the world, and then when you install it, you destine that to London or Dublin or Berlin. The disadvantage is that takes time. So 1,000 devices will take around 250 man-days to provision. This is taking account that it's 60 minutes per device, and it's going to take 4 hours per day to install in those devices. And the other thing is that it could be hard to change when things go wrong. You still need someone that goes there and fix that thing. And this is talking about like traffic sensors, but imagine that you have something in the middle of the ocean and you need to send someone there to actually fix it. And then you have the runtime provisioning, which is the ecosystem sets the identity. So you deploy those devices, you deploy the traffic sensors and the traffic lights, and when they connect, they actually are going to get all the information that they need in order to get provisioned with the system. That's how we do it in the cloud. So if you are familiar with Kubernetes or any of the orchestration system, the frameworks that we have, that's what they do. Our containers they don't know where the database is. They don't know what the username and password is. That get injected during runtime. So the advantage of this is that we have standard devices out of the factory. They're easy to change, and it's a very fast deployment. And the disadvantage as well, you need an ecosystem capable of doing this. In this, we're going to do an IoT project exercise here. So Acme Corporation has deployed 1,000 devices that will measure car flows and update traffic lights in a metropolitan area. Let's say that we want to do that here in London. So this is pretty much how it is. So you have traffic sensors are going to send data to AWS IoT Core. Then you have some business logic running in here. And then you're going to update AWS IoT Core to update the traffic lights. It's very simple. You can complicate it as much as you want, but that's pretty much the overall of it. So the first thing you want to do is that you want to put some firewall or some security on those sensors. You want to protect them. And that's, I don't know how many traffic lights there are in London. I should have done that, but there's a lot of them. And imagine doing that one by one. And then on top of that, you need to put certificates into each one of those devices. So imagine that instead of those devices being on the open internet, you can have them into a private network. Just putting them into a private network, you remove a lot of the complexity. So you have all those devices that have a static IP. You can access them whenever you want. It's like they were in your office. And then if you want to go a step beyond, you still have to put certificates into each one of them. You can automate that, or however you want. But then you as well can use some messaging service where those certificates are going to be into. We in ASAVI provide that messaging service. So your devices, they don't need to hold the certificates. It's actually embedded in the network. So when you want to talk to AWS, that traffic is encapsulated into a TLS connection, and AWS is going to authenticate you, and that's per device. So the device itself doesn't hold any critical data that it has. This is really, really good for headless devices where you have flash data into it, or you have like a really small processor for microchips that they don't have a lot of power to establish a TLS connection. But what about Greengrass? Let's say that you want to do this in Greengrass, and then you have a very powerful computer where you can put stuff. So this is pretty much how it works. You have a human that it's gonna try to connect to the edge gateway, but the problem is that edge gateway, it's behind a NAT, is in some sort of network behind the telco operator or something like that. So to get to that, it's almost impossible. So what you need to do is to physically go and connect to it, install Greengrass, talk to AWS IoT Core, get the certificate, and now the device is able to talk to AWS IoT Core, and after that, you're golden. That device talks to AWS IoT, you can manage it, you have device shadows, AWS has really, really good a really, really good framework around this. But there's a better way. So what if you had a private network, and then in that private network you can extend it to AWS? Now you can have some sort of orchestration server that is on the same network as those edge devices, and you can have something like Ansible that can go through SSH, install your Greengrass, run all the tests, and now this thing is connected to AWS IoT Core. So this is where we are going now. Like, a lot of people is choosing to use this because the flexibility of the, like, let's say that you are disconnected from the internet for a long time and your certificate is not valid anymore. And as soon as that device comes online, you can trigger that event and install everything again on that device. And after that, the orchestration server just disconnects and the devices are all happy talking to the internet. So that's how you can solve the provisioning of IoT devices in a very simple way. You don't have to worry about if that devices go, because imagine in a moment like, yeah, the device is provisioned, but now that device is out there in the internet and you can't reach it. So it's very hard for you to go back to it. So if you have it in a private network, you can actually get to it at any time. So kind of a recap of what we did here is that plan for change. So when you do a deployment in IoT, think about you're not going to have a very reliable connectivity all the time. Even if you are in Wi-Fi, like, people think that Wi-Fi is easy. Like, how many times you go into an office and your computer doesn't connect and you have to get the IT guy to come and connect it. Imagine that in a factory or something like that. Private networks are allies into your IoT deployments. Provision as close as possible to your runtime. That will solve a lot of issues for you. And treat devices as commodity hardware. That's where we want to get to. The same way that you do that in the cloud for VMs, we want to get to the same point in IoT. And that's going to be the moment where it's going to be really easy to do the development in IoT. That's me today. Do you have any questions?
Roving mic, if you need me. Any questions? No. That was so spectacularly detailed. Nobody could possibly have a question. All right. Round of applause for Richard already. Thanks very much.
Sure.